Now children, we will start the chapter chemical bonding. What happens during chemical bond formation? Or why do atoms form bond? Atoms form bond in order to stabilize themselves by attaining octet as much as possible. Wherever the scope for octet, otherwise where the scope is for duplet, they go for duplet. So atoms undergo bond formation in order to attain stability. While doing so, children, some energy change takes place. Remember, during chemical bond formation, there's always loss of energy. Energy is released, or say it is always essentially an exothermic process. So I gave the point chemical bond formation is always exothermic process. Point number one. Then comes children, this is how the energy change takes place during chemical bond formation. Now, how many types of bonds do we have? We have basically two types of bonds. One is ionic, second is covalent. One is by complete transfer of electrons and other is by sharing of electrons. Because these two only possibilities are there. Either they can give and take or they can share. So on the basis of this, we have basically broadly two types of bonds, ionic and covalent. Remaining what all you will study, they will be the modified forms of either of these bonds. Now children, the first bond we will take up is ionic bond. Some idea you have already for this. Now, first point, it is always formed between a metal and a non-metallic atom. I hope you all know this also. Number two, during this process, complete transfer of electrons takes place. Complete transfer of electrons takes place. The atom which gives out electrons gets converted into a cation. The atom which takes up electrons gets converted into an anion. These oppositely charged ions get attracted towards each other and remain held together with the help of electrostatic forces of attraction or Coulombic forces of attraction. So, this is how the ionic bond is formed. Now, factors favoring ionic bond. Low IP of metal atom. Metal atom should have low IP so that it can easily give out electron, less energy is required, easily release of electron and easily cation is formed. Second, high EA of non-metallic atom. The non-metallic atom should be easily accepting electrons so that good amount of energy is released and we say high EA for non-metallic atom. So metal atom should be easily able to give out electron and non-metallic atom should be easily accepting electron. So that metal atom should have low IP and the non-metallic atom should have high EA. Good amount of energy should be released. That shows high EA. Then children, the two combining atoms where one has to be metal, other has to be non-metal, they should have good difference of electronegativities. It is seen if they have difference of electronegativities En 2 or more than 2, then only good ionic bond is formed. The difference of En should be 2 or above 2. It is seen children that if we have difference of nearly 1.7, books report 1.7 nearly, then a bond was found to be 50% ionic and 50% covalent. Above this, gradually ionic percentage was increasing. Finally, it was found the difference of En should be either 2 or above 2. Then only a good ionic bond is formed, right? Otherwise, very rarely we have purely compounds, we rarely have compounds having purely ionic bond or purely covalent bond. So a good difference of En favors ionic bond formation. where the value should be 2 or above 2. Difference of En means difference of electronegativity. Then we have the compound there should be good high lattice energy. There should be involvement of high lattice energy. Now children, details of this lattice energy you'll be taught in different chapters, rather even in next year also one chapter, solid state. Here I'm just giving you an idea, and some idea you'll be given during chapter thermodynamics. Here, what is lattice energy? I'm giving you. Lattice energy is energy liberated in condensing the required number of cations and anions to form the lattice of 1 gram mole of an ionic compound. I repeat, it is the energy liberated, released in condensing the required number of cations and anions to form the lattice of 1 gram mole of ionic compound. Now you will say, what is this lattice? Lattice means arrangement of ions or particles within a compound. If it is ionic compound, then ionic crystal. If it is covalent compound, then the atoms there. So the arrangement of ions within an ionic crystal is called lattice. Energy released during the formation of that lattice in forming the arrangement of those ions there is called lattice energy. Lattice energy, in short, is that amount of energy released which is required in the formation of 1 gram mole of an ionic compound. What all number of ions are required for the formation of 1 mole of ionic compound during that process, and condensing those process, arranging those atoms, ions together within a compound during the formation of its 1 mole is called its lattice energy. So energy liberated in condensing the required number of cations and anions. Say example, you have calcium fluoride, then 1 mole of calcium cations and 2 moles of fluoride anions required in the formation of lattice of 1 gram mole of ionic compound. If I want to make 1 gram mole of calcium fluoride, for that I need, the formula is what? CaF2. So I need, for 1 mole of calcium fluoride, I need 1 mole of calcium ions and 2 moles of fluoride ions. So energy liberated in condensing the required number of cations and anions to form the lattice of 1 gram mole of ionic compound is called lattice energy. So higher the value of lattice energy, this also favors the formation of ionic bond. Now, what all factors favor lattice energy? So here, smaller the size and higher the charge on the ions, greater will be the lattice energy. What happens, children? If the ions are small in size, so the internuclear distances will be smaller, they'll be more close to each other and they'll be more tightly held, right? Similarly, if they have high charges, they'll be easily attracting each other. So we'll be having good bond formation and lot amount of energy will be released. A bond which is strong means a good amount of energy is released, a high amount of energy is released in the formation of that bond, to which we call bond energy, right? So smaller the size and higher the charge on the ions. I repeat, if the ions are smaller in size, internuclear distances of those ions will be smaller, they'll be more closer to each other, more closely present over there, they'll be attracting each other more tightly, more closely, and will be forming a better bond. Then if they have high charge, again more force of attraction will be there between two of them and the bond will be strong. And during this process, good amount of energy is released. So these factors, like smaller the size and higher the charge on the ions, greater will be the lattice energy and greater will be the condition of favorable will the condition for the formation of ionic bond. As it says, higher the lattice energy or high lattice energy favors ionic bond formation. And what all factors favor ionic bond? This lattice energy, smaller size and higher charge. These favor higher lattice energy, and higher lattice energy means condition favoring ionic bond formation. Then children, properties of compounds having ionic bond, or say ionic bond itself. Ionic bond is non-rigid. In simple words, I would say it is not a very strong bond. You see, with the help of water, those electrostatic forces of attraction, they break up and they separate out in the form of ions. So bond is not rigid. Then it is non-directional. Non-directional means, children, the charge like NaCl, the positive charge on the Na ion is evenly distributed around the whole of Na plus cation. Similarly, the minus charge on the Cl minus is evenly distributed all around it, around the Cl minus ion. So Na plus ion can attract the oppositely charged ions, and Cl minus can also attract the oppositely charged ions from any direction and all direction, and as many as possible. Now how many possible? What all can be physically accommodated within that space according to their size. Hence, in short, non-directional means the charge is evenly distributed. Charge evenly distributed. So the bond is non-rigid, not very strong, and the bond is non-directional. Often asked in your competition, especially this point, ionic bond is dash, non-directional if the options are given. So it is non-rigid, not very strong, and non-directional means the charge remains evenly distributed all around the cations and the anions. So cations and anions can attract the oppositely charged ions accordingly from any direction and every direction, and as many as possible. And that varies from the compound to compound. That's why they have a proper 3D structure, which you will be taught next year in the chapter solid state. You are taught the structures of NaCl and many other compounds. So it is like this. So non-rigid and non-directional. Then the compounds have the properties of compounds: high melting point, high boiling point. You all know. It's all because of strong electrostatic forces of attraction. Children, they are just forces of attraction. They are strong, due to which they have high MP and dP. The compounds are hard, they are brittle, they are solid, crystalline. No ionic compound exists in liquid state or gaseous state. All are hard, brittle, solid, crystalline, and soluble in water. As well as you also know, they conduct electricity in their aqueous solution or molten state. I did not write this because this you know from lower class, right? From 9th and 10th all. Then examples which you have in your syllabus is sodium chloride. You had its whole detail in class 10. Lithium oxide you can also do, because I have shown you one example. So the way it is lithium oxide, NaCl you had last year, MgO you had last year, calcium oxide you had last year. Then it is magnesium fluoride as well as sodium sulfide. So children, like you had last year calcium chloride, on the same lines you have magnesium fluoride. So all these you can do. For you this is slightly new, and say this is slightly new. This is as good as calcium chloride which you had last year. Calcium oxide, magnesium oxide you had, they are similar. You had NaCl. So out of this Li2O and Na2S, you see similar. Li2O or Na2S. This kind of, this example was not there. So I have taken this for you. So what is there, children? This is our sodium atom, 281, 281, and sulfur 286. 6 electron in the outermost shell, and Na have 1. So they are giving the electrons. Now what happens? Na becomes 28, positive charge, and sulfur becomes 288 and charge is 2 minus, and now you see here Na plus plus S 2 minus minus. I wrote here, I am not showing electrons anymore now here, and Na plus. So this Na and this sulfide again are getting attracted and will be held with the help of these Coulombic forces, or say electrostatic forces of attraction. Similarly, this sulfide and this Na, this side also will be attracted with the help of and held together with the help of electrostatic forces of attraction. Thus, finally we are showing Na plus whole twice and sulfide. So this is all you need to know for your ionic bond in short, and the points, key points required. If you know this, I am sure you'll be able to answer all the questions based on ionic bond. Keeping in mind the time limit, we have done this. So always exothermic process, right, between metal and non-metal. What is the exothermic process? Chemical bond formation is always an exothermic process. Then metal and non-metal, transfer of electrons. These points are there. You will note down these points, and I know a lot of points and a lot of things are already known to you. It is just a revision and simple thing. So for this video, I stop here. You will note down the notes and try to understand. Okay. So this is for this video. Thank you, children.